One of the things I've been alluding to throughout the past few videos is the idea that atoms can lose and gain electrons. And in fact, most atoms have this ability to lose and gain electrons, and some elements, depending on what they are, do it really frequently. And this gives a really unique property to those atoms. It creates what we call a charge. And that charge allows those atoms to do things that other atoms can't do. So that charge is a really important idea, and it leads to what we call an ion. An ion is an atom that has either lost or gained electrons, and this creates an imbalance. So you end up actually having a little bit more positive or maybe a little bit more negative inside of that particle. And what ends up resulting from this is what we call a charge. So when it comes to these ions, one thing we need to be able to do is figure out the charge on an atom. So if an atom loses or gains electrons, that's something we have to be able to calculate and be able to show to anybody who might be looking at the work that we're doing. So what I wanted to take a look at were some of the different types of ions that we can encounter. So the first type of ion is what we call a cation. And that's why I worked in a picture of my own cat, just to any excuse to talk about him. Okay, but a cation is something that has actually lost electrons. And this ends up resulting in having more protons than you have electrons in that atom. And because your protons are positive and electrons are negative, you get what's called a positively charged ion, or a cation. I always like to remember this because cations are positive. Now, just to give you this visual representation, let's say you had something with 5 protons. That's like having 5 positive charges. And if that thing loses an electron and now only has, 6 protons, and it loses an electron and now only has 5 electrons, then that means you actually have more positives than you have negatives, resulting in an overall positive charge. We can actually calculate how much this charge is because the amount of charge is directly related to the amount of protons and electrons. So let's take a look at an example. What would be the charge of sodium if it lost 1 electron? So what we want to do is take a look on our periodic table and find sodium. And then the next thing we're going to need is the number of protons and the new number of electrons. Sodium has 11 protons because that's its atomic number. And that means that normally sodium would have 11 electrons, but it has lost 1 because that's what we were told. So now it has 10 electrons. Now keep in mind, each of these protons carries 1 positive charge. So the overall charge is the 11 electrons combined with the 11 protons combined with the 10 electrons. And remember, electrons are negative. So that's like subtracting that number. So the overall charge that we get is a positive 1. And actually, if you lose electrons, this will always result in a positive charge. However many electrons you lose is what that positive charge will be. So then how do I actually represent a sodium atom that has a charge of positive 1? Well, what I would do is draw the symbol and then as superscript, so that means a little number in the top right-hand corner, I'm going to show the charge. In the case of +1, we usually just write a plus sign, and that represents a positive 1. So let's take a look maybe at another example where we don't have a positive 1 as the charge. So let's say we wanted to find what is the charge of, let's say, boron if it lost 3 electrons. Well, remember what I said last time? Losing electrons automatically tells you this has to be a positive charge. How many? Well, it lost 3, so it has to be a positive 3. If you wanted to do all the work, you could say, okay, boron has 5 protons. If it lost 3 electrons, it now has 2 electrons. 5 minus 2, well, that's going to give me a charge of positive 3. But how do I represent this? Well, what I do is write my symbol for boron, and then I write the charge as superscript in the top right-hand corner. Now, in chemistry, it is convention to write the number first and the sign after. Why? I actually have no idea. I don't know. And it's not really important. It's just what most people do. If you want to do it the normal way and put the sign in front, I don't think anybody's going to punish you for that. Okay? So that's how we end up dealing with cations. Remember, a cation always has a positive charge. Now, there's another type of ion, which you've probably guessed by now, but this one is called an anion. And an anion is an ion that has gained electrons. And because it has gained electrons, that means that it has an overall negative charge. It has more electrons, which carry a negative, than protons, which carry a positive. And I always like to remember this because I think of anions as a negative ion, anion. Just to give you that representation. Now, let's say we had something that had 5 protons, and all of a sudden it gained 1 proton, so now it or 1 electron, so now it has 6 electrons. That's going to tip those scales, and now you're going to get an overall negative charge. So now that we have this idea of how anions work, let's take a look at an example. So what would be the charge of sulfur if it gained 2 electrons? I just want to clear something up. I'm Canadian, so I use British English, and so I use pH when it comes to sulfur. Often you'll see it written with an F, which is the American spelling if you wanted to use that. But they are exactly the same thing. It's just different ways of spelling it. So when we're dealing with sulfur, well, sulfur is going to have 16 protons. So then let's think about electrons for a second. Number of electrons, well, it's gained 2, so it has to have 18. Now, remember, I said you want to combine those 2 together, but in this case, you end up having more negatives than you have positives, so you end up with a -2. So how do we represent this? Well, sulfur symbol is S, and as superscript, we would write 2 minus to represent that charge of -2. Okay, should we do another example? Before we do this, I should point out anything that gains electrons will always get a negative charge every single time. And how much? Well, however many electrons it gained. That's ultimately how you can figure out what the charge is going to be. So here's going to be the next thing that we deal with. How many, or what would be the charge of, let's say, phosphorus if it gained 3 electrons? Well, I know right away from reading this, gained, negative. Negative what? -3, because it gained 3 electrons. So to represent this, I draw the symbol for phosphorus, capital P, 3 minus, to represent the charge. So really that's all there is to it, and it's really important to recognize that charge because that charge totally changes the properties of that material. Something like sodium, which was my first example, sodium as a metal, as an element, is actually a very reactive, highly explosive metal. But when you think of sodium, you probably think more of salt, the stuff that you need to eat, that makes your food taste good, that keeps your body running. And that is sodium as an ion. You see, sodium as an ion is extremely different from sodium as an element. And that one electron that it loses makes a huge difference into the way that it works. And so it's really important that we take these into account. Now there's one other thing that I wanted to show you about ions. What I wanted to show you about ions relates to the periodic table. Remember, when we originally learned about the periodic table, I mentioned there is this number in the top corner, and this is the common ion charge, meaning that this is the charge that hydrogen will usually take. Hydrogen usually will lose one electron. I should mention here that those are common and not necessarily always. There are some cases where something may form an ion that's not written on your periodic table, and that's okay, that happens, and deal with it. What we should recognize, though, is a major pattern that reveals itself when we look at the periodic table. If you were to look at all of the ionic charges on your periodic table, you would notice that something kind of strange happens. You notice that it goes +1, then +2 in the next column, +3, +4, and it continues, and it's kind of weird in the middle, but if you look in the 13th column, +3, 14th column, +4, 15th goes -3, 16, -2, 17, -1, and 18, no charge. There are common charges that actually appear in each of the columns. Column 1 typically takes an ionic charge of +1, 2, +2, +3 in 13, plus or minus 4 in 14, and then it walks its way down through the negatives. So -3, -2, -1, 0. You see, the reason why has to do with the structure of the atom. All atoms want to get to the point where their valence shell is full. And if we think back to the structure of the atom, inside the nucleus we had the protons and neutrons, and then we had our orbitals. And remember, those orbitals held specific numbers of electrons. 2, 8, and a third orbital that also held 8. Atoms in the same column have the same orbital shapes, just maybe a few extra orbitals. And so what ends up happening is they want to actually gain or lose electrons to fill that outermost orbital. The other trend that starts to appear on the periodic table is everything on the right-hand side of this staircase that walks down the periodic table has a positive charge. Everything on the left-hand side has a negative charge. You see, everything on the left-hand side of that staircase is what we would call a metal, and metals lose electrons. They just don't hold their electrons as tightly. Everything on the right-hand side of that periodic table of that staircase, those things are non-metals, and non-metals like to gain electrons. And so what you typically find is metals become cations and non-metals become anions. And this is just a few of the trends that we actually end up seeing in the atom, but this all is about ions and charges and all of those things that we see. Now, this is important because it will lead us to one of the types of compounds, because when we have things that lose and gain electrons, they had to lose and gain them from another atom. And when that happens, we create what's called a compound. And that's what we're going to start looking into next. So thanks for watching, and I'll see you next time.